I'm going to start recording. Okay, so we're starting day 4 of this program. We're going to review some of the stuff we did yesterday. Like I mentioned before, everything we've learned so far, we're going to constantly use. We're going to be cycling over them, and they will become second nature, okay? So, so far you've been drinking from a fire hose, and that's kind of intentional because I want us to get over all these basics very quickly and get into the actual stuff, actually doing stuff. So some of it will not stick right now, that's understandable. But once we start actually, building software and writing programs with it, then they will stick because you will use them. So we're going for a more empirical style of learning. Okay, so it's more experience-based rather than just memorizing a whole bunch of code. So I'm going to share my screen and okay, can everyone see my screen?
Yes.
Yeah.
Oh, sorry, I'm sharing the wrong class.
Yeah.
Here. Yes. This is the one I need to share. Okay, so we're going to pick up from where we left yesterday, but just a quick recap. Yesterday we talked about control statements, right? We talked about conditional statements, and we talked about loops, right? Remember the conditionals were the if-else. That's how you have the program perform one action or another based on a condition, right? And that condition is usually, an assessment of data one way or the other, right? And remember we had the if-else or if-else, if-else. And then we also had the switch, right? And case type of conditions. And remember I said that if you have too many else if, else if, else if, change it to a switch statement. That's the best practice for it. Okay? So, and then we talked about loops. Loops are a way of making a block of code run multiple times. So rather than copying it and pasting it, the exact same thing, you put it in a loop and it will loop over it as long as the condition is true. And we talked about the for loop, the while loop, and the do while loop. And I remember I said the difference between the for loop and the while loop and the do while loop is that the do while loop will always execute the block at least once, even if the condition is false. But for the for loop and the while loop, the condition must be true for the block in the loop to execute. So it will execute as long as the condition is true. Now, if your condition is messed up where it never becomes false, your loop will loop forever and your program will crash. Eventually, you'll use up all the memory and just crash your program or crash your computer. Depends on what the loop is doing. Okay. We also looked at arrays, and arrays are a very, very fun part of programming. You use them a lot. Arrays are collections. So an array is a collection of elements. Each item in an array is called an element of an array. So an array is an ordered, indexed collection of elements, and arrays are zero index, which means the first item in the array is at position 0, not position 1. Right, so it starts from 0 on. You get used to that because we find that when you're programming, the first number is 0, not 1. So you go from 0 to 9, that's the first 10 numbers, right? And so on. So when you work with arrays, you're kind of like, okay, if I want the 5th item, you subtract 1 from it in your head and go to index 4, and so on, okay? And then the last thing we did was we looked at functions. And functions are a way to write code to be reusable. So if you have a block of code that you want to use in many different parts of your program, you create a function, and then what you do is you call that function. right? You call the function, and I mentioned that you can pass a parameter to a function, right? And when you pass a parameter to a function, it is passing data into that function. That parameter is a variable that's available only within the function, okay? And then the function can operate on that variable and do whatever you ask it to do. So today we're going to pick up from functions. We're going to look at functions more. We're not going to look at too many different things today. We're going to look at functions. We're going to look at JSON. That's the JavaScript object notation. And we're going to look at classes. And this is ideally, this is the goal is for classes to be the final topic, right, in the JavaScript fundamentals for this group. And then we'll go into other things tomorrow that are not strictly programming, but more work as a developer, getting us ready to split into squads. Okay. Any questions so far before I jump in? Okay, so let's talk about functions some more. And we're gonna work with all the different things that we've done, loops, arrays, and stuff, and use them to explore functions more. But we'll also look at arrays a little more and come back to see how functions can be used with arrays. Okay. So if you remember, a function is defined with the function keyword. Sorry, I'm talking about Visual Studio Code. So if you remember, a function is declared with a function keyword and then the identifier for the function, right? And then this here is the parameter passed into a function. Parameters are also called arguments. So you have some people say, the arguments for a function has 5 arguments, or it has 2 arguments. Or a function has 5 parameters, or it has 2 parameters. They're saying the same thing, right? The parlance varies from person to person. But the technical terms, the right terms to use for, for the data you pass into the function is a parameter or an argument. All right, so we have this function here. There are different ways of defining functions. This is one way, and this is the most basic way of defining a function. Let me pull this up, and we're going to look at the different ways of defining a function. So a function declaration is what we have there, right? It is using the function keyword, right there, and then the identifier for the function, okay? Now, I have a statement at the bottom here. This is cherry on the icing on the cake, in that I say the function is hoisted. And what this means is that functions kind of break the rules in terms of execution flow, right? Remember I said a program is a series of statements and they're executed line by line by line by line by line, right? When something is hoisted, that means before the program starts running, it is taken and actually virtually put at the top. So any function that you declare, right, is hoisted. It's always available, even if it is the last thing in the code. So if I take this function here, right, that I've declared here, and I put this down here, and I run this. My terminal is jacked up. Again. Okay, so if I run this again, no, right? My function still works, even though I declare it after I use it. And that's because it is hoisted. That's an important thing to remember. Some interviewers like to ask that, what is hoisting, right? They use that to throw a lot of people out.
Can I ask a quick question on that one?
Yes.
Is it bad practice though to do that? Because doesn't it mean the code's got to read? He's got to go and look for it down below.
Yes, it is not best practice. So personally, I wouldn't do this, but it will work, right? So best practice is to declare your functions at the top before you use them, because it makes it easier to read and easier to maintain. Okay? So that's a good question. It's not best practice, but it will work because functions are hoisted. You know what else is hoisted? Variables declared with the var keyword are hoisted. So normally, if I declare a variable here, right? If I say let name equals John, right? And I say console.log hold on a second. And I say here console.log name. I screwed this up somehow. There you go. That. Right? If I say this is fine, right? I'm going to just comment this out so that we can see it. Right? We get John. If I take this line here and I cut it and I put it on the next line here, and I try running this, it will throw an error because it's going to say cannot access name before initialization. So I'm trying to access it before I've initialized it. That's the error. Let's see what happens if I change this to var. I come here and I run this. Undefined. It didn't throw the error that it wasn't initialized, right? But it had no value because I'm setting the value after John. So the difference between let and var is that variables declared with a with a var are hoisted. And hoisting means that the program knows about it. Even if you haven't given it a value, it knows about it. So when you run the program, it actually scans it for all the vars and says, oh, okay, I'm going to have a variable called name. And it prepares for it before it starts running. And then it will only assign a value at this point, right? It's best practice, don't do this because this can allow your code to not throw the right errors. You want to declare variables before you use them. This will allow your code to actually run and not throw an error. But you see, there's no value in there, which is misleading. You think everything is good, but you actually don't have a value. So it's much better to use the let keyword or the const keyword because those are stricter. Now,
sorry, I don't understand why it's returned undefined instead of John.
Because you see at this line where we're running it, it's not assigned yet. The assignment happens after the console log, not before it. So it returns undefined because the program says, okay, I know of that variable, but it has no value.
Gotcha.
Right?
Gotcha.
It won't have a value until the program runs until up to line 2. But it won't throw an error because
it found var.
The interpreter, yes, found var. So it's like, okay, I know what name is, but name has no value. Now, if I do let here, right?
Still sounds a little dumb in a sense.
Yeah. Now, this is how JavaScript worked before ES 2015. And
I don't understand why you call it a dumb cousin.
Yes, so it's, yes, it is. It's
It's
still
a
hanging around.
smelly cousin.
Yes, yes. Okay. All right. So let's proceed and let's get back into functions. Okay. So if you use a function declaration, it is hoisted, right? Which is good for reusable code that you want to be everywhere. But there's another way of declaring a function that's not hoisted. Okay. So the function declaration still uses the it still uses the function keyword, right? There's what's called a function expression. This also uses a function keyword, but you store the function in a variable, right? And because the variables are not hoisted, the function is not available until it is declared. So here, I can actually say, instead of doing this, right? What's that function? Calculate circle area, right? I'm going to take.
Excuse me.
Yes.
Is
Hold
it
on. Hold
okay
on.
if-
Yes. Please let's not ask questions until I'm done, so we don't keep interrupting. All right. I'll pause and ask for questions. Okay. So
I don't want you to go far. That's why.
yeah. Just wait for me. I'll pause. I'll pause periodically. Okay. So the function expression, that same circle area function, I can declare as const circle area equals function, and I can declare this like that. Now, if I run this, previously we didn't have a problem with this, right? And I'm going to take the console log, I'll uncomment that so it actually works. If I run this now, this time, we get the same problem here. Cannot access circle area before initialization. But if I take this, right, and I move this down here, and I run that, then it works. Okay, this style of declaring a function is called a function expression. The other style that we used before is called a function declaration. This is an expression because it has an assignment operator in it. So usually when you have an assignment operator, that's called an expression. So this is a function expression. Saying function with an identifier is a function declaration. Okay, any questions?
Stupid question here.
Yes.
Why would I do it as a variable? What's the advantage of that?
So there are many advantages to that. Usually you do that when you want to pass it as a parameter to another function, right? Because you can pass a parameter, you can pass a function as a parameter to another function and then use it. And let me show you that here. So let's say I have a function right area, right? And this takes call me, right? And radius, right? So if I do that here, and then here, I'm going to now call, rather than calling circle area, I'm going to call right area, right? I can pass it circle area, and I, right? And then what happens now is that here, my first variable call me, you can see if you look at Visual Studio Code, you can see that it's a parameter right there. So if I say call me, right, radius, Then here I can say console.log, right? Area was called. This is a pretty complex style, right? This is a pretty complex use, but you will see it eventually at some point or the other where you're going to do something like this. So I'm passing it in here. So in here, I can call that function again. And there's reasons for that. I won't go into that right now, but that is part of the reason you do a function expression rather than a function declaration. It is also because you want to make sure that the function is declared before you try to use it. So the reason might be, hey, I don't want to use that function before I declare it. I want to force the execution to have it declared at the point I need it and not just sit there in memory if I don't use it. That's one case where you can also use a function expression. Okay.
Okay, so my own question is, I actually wanted to ask the other time that can you please erase all these things and let's start and follow you as you are going? Because it's kind of confusing as we are moving up and down, copying and pasting.
Yes, I will get there. I'll get there because I'm trying to, so my style, I'll cover the subject and then we will practice it. Okay. So just follow me. I'll take a break and then we'll practice it. All right. So now for the next style, and this is very specifically ES 2016, right? There's, or ES 2015 or ES 6. There's what are called arrow functions. Arrow functions are essentially a way of declaring anonymous functions, but it's a shortcut. It eliminates the function keyword. It just makes your code a lot cleaner and a lot smaller, but it eliminates certain aspects of functions that you would typically have to type out. And I'm going to show that. Now, what is an anonymous function? Remember, with function declaration, you have the function keyword and then you have an identifier, right? As such. Well, as such, I'm not going to erase it. So you have function, right? Circle area. That's how you do a function declaration. With an anonymous function, there's no identifier. You see this here that we saved in circle area has no identifier there. It's straight function and then the parents immediately. This is called an anonymous function because it has no identifier. Okay? Arrow functions are another way of writing this. So rather than writing this whole function here, I would say const circle area is equal to and that's why it's called an arrow function. Okay, so I'm going to remove this line here. And if I run this, we'll have the same. Sorry, hold on. Radius is not defined. Oh, yeah, because it has a parameter. So adding parameters to arrow functions is the same. Yeah. Okay. This is a different style of writing function. So rather than writing function and then open the parentheses, you just eliminate that and you create an arrow. This is the style that we will be using. This is the recommended pattern because this is the ES6 pattern. This is the latest pattern of writing functions. So when you start working or writing code and other people look at it, they will look for whether you're writing anonymous functions out in full or using arrow functions. There are many other benefits to arrow functions, but I'll talk to them as we keep going talking about functions. Okay? So you will see this a lot more. I promise you. You'll see arrow functions a lot. Just remember that whenever you see two parentheses followed by an arrow, that's an arrow function. Okay? The difference between arrow functions and like a function declaration is that a function declaration requires an identifier, right? For you to have a function you can call. If you don't have an identifier, it is impossible for you to call that function. So arrow functions are usually used as parameters as well to other functions, but rather than saving it in a variable, if you don't want to use that memory to store the function, you just pass it in as a parameter. They're also used for what we call callbacks, right? Callback functions are typically anonymous functions, and just use arrow functions. It's all Greek right now, but we're going to play with them, and it will make a little more sense. Okay? All right. So we've seen everything about declaring functions. That's how you declare a function. One last thing that we'll talk about before I go and we do some examples with functions is functions can return a value, right? So far, the functions that we've been using do not return any value, they just do something, right? But you can actually have a function give you a response back when it's done, right? So let's say, for example, if we wanted a function that squares numbers, right? We want to pass a number to it and we want it to square the number, right? We can have that function return the squared number. So for now, we've just been using a console log to show that we've called a function. Let's assume we don't want to do this here, right? Let's assume we want it to return so that here, right, we can say and then we say console.log my area is area. This is a slightly different approach. We're calling the function here. Sorry. Let me change this here. This is circle area, and we're passing it I. So we're calling the function here, and the value we get back from it, we're saving in this variable so that we can use the value we get back from it later, right? We can take that value, we can say area, I would say times equals 2, right? That's one of the reasons we'd want it to return, so that if we want to perform other operations on it, we can. And this will give us the area doubled. So if I run this now here, I have a bug. Oh, assignment to constant. All right. So you see the error here we have is that we have a constant variable. It's not allowed for us to do this on a constant because we're trying to change it. So I need to change this to let. So if I save that and I run this again, now all our areas are now doubled. So whatever they were before, they're now all doubled. So we had some here that were, I don't know, maybe odd numbers like this one. They're now all double. So that's now 6 instead of. Okay, so that's the return value of a function. The function can return a value. Now let's say we only wanted this this function to return the area for even numbers. We can have a condition here, right? We can say return. I'm going to use the ternary operator here just to bring it back. So we'll say return. I will say area modulus 2 equals 0, right? We return the area. If not, we return odd number. Do we remember what this is? Question mark. This is an if else. So essentially, if area is a multiple of 2, which is what this modulus is, so the remainder of dividing area by 2 is 0, which means it's an even number, return the area, we're good. If not, tell us it's an odd number. And so, if I come here and I run this, we're only getting areas that are even numbers. All the areas that are odd numbers are being skipped. Any questions?
Oh, sorry, go on. I have one, but I think just with me, I'm getting confused why you declare a constant area at the same time. It's literally you said let area also equal. Is that not a conflict, or is it just it's doing that and then changing it later down? Is that what you're doing? It's going from a constant.
That's a good question.
On line 8 and then on line 13 is now
right. That is a good question, and you do bring up a topic that was going to be the next one, which is talking about variable scope. This area right here, right, is inside the block of the function. Is that correct?
correct. Yes. Okay.
And
yeah.
that means that it does not exist outside this function.
Got you.
It is invisible outside the function, which is why I didn't get an error, right? This area here is within this block. It only exists here. And it only exists every time this loop runs, it creates a new one, which is why you don't get an error saying, oh, it's previously been defined. Because once it runs and it's used, it's destroyed. And then it comes in again, creates it again, uses it, destroys it. Creates it again, uses it, destroys it. So this area and this area here are isolated from each other because they're in different blocks. Okay? If I declared const area right here, right? I save that and I try to run this, right? What's in here is still isolated. You see that? Because it's in the block. So whenever you have variables declared inside a block, they have what is called private scope to that block that they're in, right? They're function scoped into the block that they're in. So you can work outside of the block, it won't affect them. There are more complex structures later. There's what we call closures, for example, that can change how that behavior happens. We're not even going to come close talking about it. But as we work, we'll encounter it at some point and then I'll explain it then. But for now, just remember that when you name variables, they're available within the block, but not outside it, right? If I came here,
yeah.
So if I came here and I said console.log area, and I save that, let's see what happens. Tells us area is not defined. You see that? It's not defined. So even though we have area here and we have area here, they're both
Yep.
only, it's kind of like someone inside the house and available outside. Like whatever is within the confines, within the walls of the house, it's not visible outside of it. Okay? So that's important to remember. And we just covered this variable scope here. And we've also talked about parameters. So let's look at functions. I'm going to clear this. I will just do a couple of quick examples. Right?
Excuse me.
Yes.
If they say that a program is hard-coded, what does it mean in this context?
So if it's hard-coded, that's a slightly complex term, but that means you have written the values, right, into the code for a program that should be getting values from outside of the code. An example is if I want people to sign up.
Just ask me what you'd like me to do, and I'll try my best.
Alexa, stop. Now, if I want you to sign up for a class, and I say, okay, provide your first name and your last name, right? And then in the code, I type in the name of the class and hard-coded the name of the class into the code, which means that in future, if I want to change the name of the class, if I want people to select a class, they can't because the code defines the class. It doesn't matter. Even if I give them options to select, it will never get captured because I have it programmed into the code to only accept one class. So it's bad practice, but when we go into practice, we'll deal with that more. Okay? All right. So functions, here's what I want to do. I'm going to create a function, right, to square a number. So we're going to say function square me, right? And we'll say number, right? Or let's say my number. Okay. And then here, we're going to have a return my number squared. Okay. Now we're going to create another function factorial, right? And then we'll add a value that we'll call start at. And in here, we're going to do, okay, let's call it factorial me. I don't know why it's something about this. Oh, okay. Never mind. Just do factorial.
You spelled function wrong.
Oh, I did? Yeah, there you go. All right. Did I spell it right now? No, maybe not. Start it right now. Okay. All right. Yeah. So factorial, we're going to have this do a for loop, right? So for let I equals to start at, right? I greater than or equal to 1, I plus plus, right? And we're gonna have the let fact equals to 1. So we're going to take this for statement here, and we're going to say fact times equals to I, and then at the end of it, we're going to return fact. Okay. Now the formula that we want to explore is, let's explore for every, we're going to do a loop of numbers from 1 to 10, and we're going to do the number n squared, right? n squared over n factorial.
I was gonna think you're joking.
Sorry?
For real.
Yes. So let's do n squared over n factorial for every number from 1 to 10. So we're going to say, so let's do our loop from 1 to 10. That'll be a 4, right? Let I equal 1, right? I less than or equal to 10. Please. Okay. So I less than or equal to 10. And then we'll have I plus plus. Okay. That's our for loop. We're going to say square mean I over factorial I. And okay, let's start this as const result is that. I'll say console.log the result for I is result. Okay. So let's take a minute to examine this. Let me run this and make sure it runs, and then we'll come back and look at it. There's something funky going on. Let's change the name. So, okay, so let's take a minute and let's look at this here. What am I missing? Anyone?
Yeah,
The only
please.
thing was your start at.
Sorry?
The only thing I can think of is your start at variable. Should it not have a number? Should it not be declared as an integer at some point?
My start at is whatever I pass in. So in this case, I'm passing in 1, right?
So where are you passing it 1? That's what I'm saying. Where are you passing it 1?
So on line 14 here, I'm passing in I mean, whatever the value of I is.
Right. Okay. So my question there was, shouldn't that be the other way around? And that's what you said. Let I equal to. I was expecting let start at equal to I.
No.
Okay.
So remember when you declare a function,
yep,
the parameter you declare is not initialized.
Okay.
It is only declared. You pass a value into that parameter, which initializes it for the function. Okay.
Right. Okay.
So if I do this, let's work that. Oops, it's nothing. So if I do this here, and I'm going to do this here, if I say factorial 3 starts at, will have a value of 3 because that's what I passed to it, right? If I say factorial 5, so if I run this here, there's something going on here. Hold on. Something going on here.
on that line too, can you explain what that star means?
Hold on, I'll get there. Okay. Let me just see why this isn't running. A second. Oh, hold on. I'm not outputting anything. Oh, I see why this isn't running. So, oh. So here it's it's undefined because it's okay. So I have an idea of where my bug is. My bug is in here. Oh, here's the reason. I'm supposed to be going down, but I'm incrementing rather than decrementing. So I have a loop that will never finish executing. So remember our factorial, we're counting down, we're going backwards, right? So it should be 1, so it should be minus. And there, okay? So let's now talk through it. So my function, square me, this is the exponent operator. This raises any number to the power provided. So this says square raised to the power of 2, or this is a number to the power of 2. Okay, that's what this operator does. So this function will square any number passed to it. This function is a factorial function, which is if you do 5 factorial, that's 5 times 4 times 3 times 2 times 1, which is why we have a loop going backwards, right? So we have a for loop that starts at the number and then decrements it by 1 each time and multiplies it with the previous number. So 5 times 4 will be 20 times 3, 60 times 2, 120 times 1, 120.
But if you want to multiply, if one of those that you're going to use.
Sorry?
If you are multiplying, if one of those you are going to use for multiplying, for multiplication.
One of what?
Is it the same sign for multiplication and the factorial?
Yes. So, no, multiplication, there are 2 different operators. They look alike, but you don't call them the same thing, right?
But on the keyboard, you find them the same.
Yes. But what I'm trying to say is that, remember I said that you're going to have to talk the talk, right?
Mm-hmm.
Even though there are 2, you don't say it's 2 multiplied. No, the 2 of them, if I type this, right, Anna, you will read this as Anna. You won't read this as A with 2 N's and an A, because this is a word, not individual letters. The same thing with programming. If I do this, that's multiplication. If I do this, this is exponent. It is not 2 multiplications. If I do this is assignment. If I do this is a comparison. And if I do this is an absolute comparison. You have to read it as one thing, not as 3 equals or 2 equals or 1 equal. Okay, so let's be careful for that. Let's call it, even though it's 3 equal sign, but when you're talking about it, you don't say triple equals.
Yeah, I just want to be sure it's the same
Right.
keyboard, the same sign on the keyboard, or maybe
Yes.
it's something else.
No, it is. It is the same one. Okay. And so those terminology, I'm trying to make sure that we use the right terms as well when we speak about it. Now we only have 2 more minutes on functions, so let's talk about this through, and then we'll move on to the next topic. Okay. So we have the square me function. We have the factorial function, and then we have this loop, and we loop from 1 to 10, right? And each time we loop, we square the number, right? And let me write this properly the way it should be written. We square the number, and we divide that by the factorial of the number. And then we output that result. We're saving it in a variable called out, and that's it right there. Okay? The reason we get the square of the number is because we have the return statement. If we don't have the return, we won't get the square. It will be undefined. So if I do this here, if I take this out here, if I comment that line out here so that the factorial doesn't return, and I run this, what do you see here? Not a number. Because I don't have this base here I'm trying to divide by, is not a number, it's undefined. So it tells me, hey, this is not a number. Right.
So is return just saying storage in memory? Is that basically what it's saying?
Sorry?
Is return just almost like saying store this in memory for use later?
No, it's actually return. So give this back to whoever is calling, right? So it's similar to if you went to a restaurant, right? If you went to McDonald's and ordered, a Big Mac, right? You tell the person there, give me a Big Mac. You're calling the function, right? The waiter or the person at McDonald's gives you a Big Mac. They return. So they're a function that return. So you leave there with a Big Mac. So that's the analogy, is that you call a function and the function returns to you something. And then you can do other things with what it returns. In this case here, we're storing it in a variable. We could actually just as well come here, take this here and stick it here and not have to save it in a variable.
Right, okay, so, sorry, but apologies for this, but my issue is, fine, you said return fact, but I don't see you use it anywhere else. That's why I'm questioning what's it returning it to.
It's returning out of the function to whatever called the function. So the return is the output of the function, right?
Okay.
Exactly the same way as that McDonald's waiter giving you the hamburger you requested, right?
Right, okay.
Right. If you didn't, if now let's say the waiter was just there to take orders. For example, it's a machine, they have these screens now in McDonald's. If you go in there and put in the order, you don't get the burger. You can sit at that machine all year and you won't get a burger because it does not return.
Okay.
It does not have a return statement, so it gives nothing back. It just takes from you, but gives nothing back. So a function that has a return is a function that returns the value. It will give you something.
No, sorry, I've got it now. I've been stupid. I've got it.
Yeah.
It's returned into the factorial function, which then used down below in your lab.
Yes. So this right here calls this function. And you can see the great thing about Visual Studio Code, I'll talk about this more tomorrow, about how it will help you program, is I've highlighted it here and it's highlighted the function. So this call here gets the value that's returned, right? So if I call the function 5 times, each one will get the value that's returned.
Sorry.
All right.
Yinka, at this point, majority of the class, apart from that, boys, is basically copying your board and getting the results, but we don't know what we're doing.
Okay.
So if it's important for us to understand it at this point, maybe let one of the students try to explain it. Otherwise we can move on to the next thing if you feel we'll
Okay.
later on.
Can I just make a point here? That's very clear. I'm literally doing the opposite. I'm not typing at all. I'm just trying to understand what he's doing. So when it comes to actually typing it, I'm going to have to get a paper with the syntax and type and follow. So I'm just trying to follow what he's saying. Because
Yes, what I'm saying is that you are ahead of the class in the sense that you understand what you're seeing. You understand? Most people don't even understand what they're seeing at all. They don't understand anything.
So I'm gonna take 5 more minutes. Okay, I'm gonna take 5 more minutes, and I want to make sure that everyone understands what's going on here. So I'm going to break it down almost literally line by line, okay, or
good
block by block. The first thing that we did here is we declared a function called square me, right? We declared a function called square me. And the purpose for this function is to take a number and square it. Like the purpose is to take a number, square it, and give us back the square of that number. That's the thinking. That's what we want from that function. So we write that function. We call it square me. We could call it anything. This is an identifier, right? We could call it anything, but we call it square me so that we know what to call. And we have a parameter here that takes the number that we want the function to square. This is our input into the function. And the function here does a simple thing. It returns that number squared. This is the exponent operator. So it returns that number squared. Okay, do we understand this so far? Right? So I can call console.log square me 4. Right? And this is going to output, let me kill this. And that is going to output 16. So this tells us that this function is doing exactly what we want. Whatever number I pass in, it returns the square of it. Okay? Now, the next function that we declared is a function that does a factorial. A factorial is that number multiplied by the previous number all the way down to 1. So if you say 5 factorial is 5 times 4 times 3 times 2 times 1. If you say 10 factorial, it's 10 times 9 times 8 times 7 times 6, etc. Right? It multiplies back to 1. So we created this function. And this function, for it to go all the way back to 1 from any number, runs a loop, right? So it would be, we have a for loop that starts at the number we pass to it, because that's what we want to do, 1 factorial. So we want to start at that number and go down and decrement. So it starts at that number, and it loops as long as that number is greater than or equal to 1. When it gets to 1, it stops, right? And here we have the decrement. And all we do is we multiply that number, we multiply the current value by, we have this running tally here that we call fact, right? This is our running tally. So it starts with 5, and then here it does, fact equals 5 times 1, which is 5. Then when it gets to the next number, which is 4, fact is now 5. So here it becomes 4 times 5, 20. Saves that back into fact. This is how you're like accumulating it. And then at the end, when the loop completes, it now returns that. So here, if we say console.log factorial 5, right? We should get 120, because that's what the function does for us. So if we run this, we get 120, because that's 5 times 4 times 3 times 2 times 1. Now, the formula that we said we were writing a program to do is that we want it for numbers from 1 to 10, we want it to do this formula, n to the power of 2 over n factorial, right? N squared over n factorial. That's the mathematical formula we want to solve. But we want to solve it for all numbers from 1 to 10. You will do things like this if you want to calculate interest or calculate, tax on a bunch of receipts, right? If someone orders 5 items and you want to calculate the tax on each one, and it's 6%, this is the kind of thing you do. You write a function that will do the 6%, and then write a loop that loops through every item, and then passes the price on to your tax. So this is the formula that we want, n squared over n factorial, which is here, n squared is square meaning of whatever the number is, divided by factorial, n factorial. So when I is 1, it will do 1 squared over 1 factorial. When I is 2, it will do 2 squared over 2 factorial. When I is 3, 3 squared over 3 factorial. When I is 4, 4 squared over 4 factorial. And if you look right here, I'm going to remove this because this is not valid code. And when I run that here, let's take the console log, put it back. When I run this now, you look at that. 1 squared over 1 factorial is 1, because 1 factorial is 1, right? 2 squared over 2 factorial is 2, because 2 squared is 4, 2 factorial is 2, 4 divided by 2 is 2, so the answer is 2, right? Now, 3 squared over 3 factorial is 3 times 3 is 9, 3 factorial is 3 times 2 times 1, that is 6. 9 over 6, 9 divided by 6 is 1.5, right? Now 4 squared over 4 factorial is 16, right? Divided by 4 times 3 times 2 times 1, that is 4 times 3, 12, times 2, 24, times 1, 24. So 16 over 24 is 0.67, right? It's 2/3. And so on and so forth. The loop works, which is why we have the numbers from 1 to 10, and our formula here works, where we have.
I have a question. Well, on my end, I have an error that I've been trying to figure out, but for some reason, it's telling me a reference error. I is not defined, and I'm not sure.
Your for statement, right?
Yes.
Do you have this let keyword there?
Yes, I can quickly share my screen if we have time, but just up to you.
Okay, so I'll say hold it till we're done, and then we'll have a session right after, right?
Okay, thank you.
Right, and make sure your keywords, everything is all lowercase. If you have an uppercase there, it will not work.
Okay, okay, thanks.
Okay, all right, so let's move on now. This is functions. We've done a lot of different things with functions. We're going to still do more things with functions, and we'll see them in use. But I want us to move on. There are 2 more important topics that I really want us to cover. And so let's look at hold on. Okay. Let's look at, we're not going to look at arrays. We looked at that yesterday. We'll come back to arrays and do a few more things with arrays that are fun. But let's look at JSON. Some people may have heard about this. Most people probably haven't. JSON is JavaScript Object Notation, right? JSON is today the de facto standard for exchanging data between systems. Okay. I don't know if you remember when we looked at the network, right? On Monday. The data that's exchanged between the browser and the server in some instances, it's actually structured as JSON. But JSON is the basis of how a lot of different disparate systems talk to each other. They exchange data in JSON. So JSON is a way of defining objects so that they can be exchanged from system to system. They don't even have to be the same platform or the same programming language. They will both see the data the same way if it's written in JSON. Okay. Now, what is JSON? How do you write JSON? And why is it important? I'm going to do a simple example, right? I'm going to clear this out. And I'm going to say, let person, when you define a variable like this, actually, you have just created an object. Remember what I said yesterday, that an object can have properties and can have methods. Properties are attributes of that object, and methods are actions it can perform. So if I go with person, if I wanted to define an individual and capture their information, their first name, last name, and age, I could create an object, right? And say first name, John, last name, Doe, age, 45. What I've just done here is I've created a JSON object. In some transactions, it's called a JSON document. But this is a keyed set of properties for a particular object. The important thing about this is that the elements or the properties of a JSON object are related because they are properties of the same object. So if I come here, I can come and say, let person 2 be first name, Jane, last name, Doe, right? Age, 35, gender, female. And let's come here and let's add a gender to this. Gender, male. You can see that when you look at this, you know that, oh, you're looking at a person, right? These are information about the person. So JSON objects are great for capturing information that's related together, capturing the attributes of an object. So it actually is an object. For a lot of people, when they create objects in JavaScript, they will just go with JSON, right? And it has its benefits and its drawbacks. I'll mention it I'll talk about another way of creating objects in a few minutes, and you'll see why JSON has its drawbacks, but why it's also very useful. Now, we have all these properties of the JSON object. You can actually access them, right? And perform operations with them, just like you would with a normal variable. You access the properties of a JSON object using what we call dot notation. And that is this. If I want to output the first name of person, right? I'll say console.log person dot first name. And that will output John. So this is called dot notation, which is on this object, dot the property. Give me the property this property of this object. If I come here and I say console.log person2 dot first name, right? That will give me the first name of person 2. So this is a way of accessing the data. I can actually also assign a new value to a property. I can say person the first name, right, equals James. And this assigns the value of James to this first name property of person. So if I come here now and I say console.log person.first name, see that first name was John here, and then I changed it here to James, and now first name is James. And if I do console.log person, right? Because it's a variable, person is a variable. That is person. This is what we call JSON, JavaScript Object Notation. Remember?
Question?
Yes.
You said like too much repetition is not good practice. And it just seems like there's two different variables with like first name, last name, age, and like, why is this, like you said, it's Jason is like this big thing. So I don't get it.
Okay. So that's a question. And I really do like that question, right? It's very exciting to hear a question like that because it means that we're following along and we're thinking. I've declared two variables here and they're almost identical, right? It makes no sense. I'm repeating myself. What should I do? I should probably create a blueprint, right? That has the structure and then I can just set the values on it. But the way JSON is typically used is to transmit data, right? Not for programming per se. There are places where you use JSON in your code, like if you're passing options, right, to a function, and you want to pass the options as a set of related, you get what I mean? So let's say I have a function that takes 5 options and then takes other parameters. You know, I might have an options parameter that accepts a JSON object of options, and then the parameters to operator, right? But the biggest use of JSON is in transmitting data. So what I would have would typically not be let person equals this, let person equal this. The way you would see JSON used the most is that you would have let people, right, be an array, and then each element in that array is a JSON object, right? And then I'll close the array here. And this here, if I wanted to generate like a list of the people in the class, right, for each person. So think of it like a spreadsheet. I have the columns, the fields. Each person, if I want to export that data, it would come out as an array of people. So this is a very, very common use of JSON, and I will show examples of it, but you will, for all the different tracks, you will encounter a lot of JSON. The backend squad will generate JSON. The front end squad will consume JSON and use it to render visualizations and UIs and do all kinds of stuff. So we can't escape JSON, right? I don't know, do we understand that, or is that helpful?
I have a small issue on my end. It's for some reason I get an error for gender, and I don't know why.
Okay. Now you have to make sure every property ends with a comma, and then gender has no comma or semicolon at the end. So comma, and then this is the key or the property, and this is the value.
Yes,
Okay.
it's underlining my gender for some reason.
Yes, so which means there's a problem probably before gender. Do you have a comma after age?
No, I don't. Okay.
That's the problem. So you have to make sure there's a comma after each line.
Okay, got it. Thank you.
Okay, so each line in a JSON document ends with a comma, not a semicolon, and then at the end of it all, you have a semicolon. Now that we have this here, let's do this. Let's have some fun with this. We're going to create a loop to loop through this collection of people, right? Because we created an array. Remember, square brackets means an array, right? A better way of writing this is actually to start yes.
Okay, so in this array, just element 0, would it be all four things of John Doe 45 mil?
Yes, element 0 will be a JSON object.
Okay, got you. All right.
Right. So now when you think about it, this array is an array of people, the collection of people. I have an error here. I didn't move my G. All right. So this is a collection of people. Each element in the array would be a person, right? So let's do this. Let's say I want to.
Question.
Yes.
You said like the curly brackets, like they start like a new block of, and then the square brackets coming in the beginning. Is it like a new block of code?
No. The square braces are how you declare an array. So whenever you declare, I don't know if you remember from yesterday, but we said, if you say let names is equal to, you've declared a new array. So we can have an array of names, which is a collection of names, James, right? John, and so forth. Oops, sorry, this doesn't like me doing that. So it can be, and so on. Come on, let me do that, whatever. So the square brackets define an array. That's how you define a collection, okay? An array, a collection can have different types of elements in it. In this case, our collection has JSON objects in it. So it's an array of JSON objects. Each JSON object is a person. So like everybody, each participant here, you have a first name and you have a last name and you have a gender and you have an age. So you think about it, this meeting is an array of people. It's a collection of people. And each person here has properties, just similar to each element in this array. Okay, so what I'm going to do is I'm going to loop through this array and just output their name and their gender and their age. Okay, so we're going to use a for loop. Let I equals 0 because arrays are 0 indexed. They start from 0. So we're going to say let I equals 0, right? I less than people.length. Remember that from yesterday? The length is how many items are in the array. And then we're going to say I plus plus, right? And here, I'm going to say let person equals equal I. This gets every step, this, every index, it gets each person in the array and saves it in the person variable. So we can play with it. And then we can now say console.log person.firstname, right? And you can see it already, you can see the properties there, right? I'm just using that to create a space. Actually, I don't need to do that. We say person dot last name, right? We say is right? Person dot age, year old, person dot gender. And if I run this, here, it says John Doe is a 45-year-old male. And it says Jane Doe is a 35-year-old female. Because we have JSON objects here. The beauty of this is I can come here and I can add one more item to the array. Let me do it from scratch. So opening curly, first name, James Jack. Sorry, first name James, right? Last name, Jack. Age, (28). Gender, male. If I run this now, you notice I haven't changed my loop at all because my length is dynamic. It's getting it from the length of the array. If I run this now, I now have James Jack is a 28-year-old. So now I have 3 people because I added a third person to my collection. So remember, an array is a collection of elements. In this case, each element is a JSON object. That's a person. And this is our good old for loop, but we're using the length of this collection as our parameter to define when to stop.
Yeah. Question.
Yes.
Why do we use comma in JSON and not semicolon that we use in the other ones?
Because this is one entire object. You use a semicolon at the end. So similar to what we looked at the array, when you declare an array here, right? If I say let names, right? Watch this. James, comma, John, right? That's because an object, this is a list of the properties of the object, right? Each one is not independent of all the others.
Oh, okay, I see.
Yeah, each one is not independent of all the others. They are all related, so it's a list of properties of the same object. So the curly brace defines the object, and this is the list of properties. So it's important to remember this is a comma. If I put a semicolon here, and I run that, it's going to break. So unexpected token, semicolon. And it tells me exactly where it is. You can see put the arrow there to say, hey, a semicolon. If I don't put a comma there, You see, it's underlined this because I haven't ended that property. I run that to throw an error. You have to put a comma after each property, except for the last one. And you try to make sure you don't put a comma after the last one because there's nothing following it. Okay?
Okay, thank you.
Okay, so we have this. This is an array of people. Now let's write a function and let's output the first name in uppercase. Right? So let's do this here. Let's come up to the top here. And we're going to create a function capitalize, right? Capitalize. Did I spell that right? One day I'll learn to spell.
American, it should be S.
Yeah, well, I'm British, so. All right, so capitalize text, and we're just going to return text.to uppercase. I'll explain what that is later. But this right here, if you pass any string to uppercase, is a method that's available on strings, and it converts them to uppercase. Right. So now if I come down here, back to this, my line here, I said I want to capitalize the last name, right? So here, what I'll do is I'm going to call the capitalize function, and I'll pass it last name. Okay. And then here, if I now come down here and I run this, my last name is capitalized. It's in uppercase. And similarly, the beauty of using a function is that if I decide, oh, you know what, forget it, I want to make them all lowercase, I can say to lowercase. Right. And there, it's now lowercase. The first letter is no longer capitalized.
But this is only for display purposes, not in the array itself. Or sorry, not in the JSON object itself.
Correct. It does not affect the JSON object. Because what we're outputting here is the result of the return value of the function. We're not modifying the array. But good question. What if we wanted to modify the array? Remember, you can set a property, right? Right now, we're just retrieving the value from property. What if we wanted to set the property and actually change the array? We could do that here by simply saying person.lastName equals capitalize person.lastName. And now we're actually saving this change. And we can come here and we can, in this case now, we are actually modifying that object. And if I console log, if I do a console.log person, so you can see that it's actually changed in the person. And let's come back here. Let's do to uppercase again. So the change I made is I am now actually assigning that change back to the property, right? I'm going to run this, and you can see now that last name in the JSON object has now been capitalized because I wrote to it. Okay, is this totally Greek or are we following?
I don't know, so
A lot of it is Greek, but I'm trying to keep up, sure.
Okay.
The concepts is what I'm good with.
Okay.
Actually, if you ask me to type it now, I couldn't type half of what you just typed. I'd have to look at the syntax and trying to recreate it.
And the context is what is important. Because you can always look for the syntax, right? But if you can think about it, a JSON object is something, a person, a thing, a house, a car, you know, an account, you know, a food, a product, anything. Almost anything that has attributes, you can create a JSON object for, because that's how you capture the different attributes or the different properties of that thing, right? So here I used people because, yeah, people have properties. So if you remember that concept, if I asked you to collect the data for everyone in this meeting, if you think about it, would you create an array that has arrays in it, or would you create an array of JSON objects? You create an array of JSON objects with each person being their own JSON object, and then you can now put their properties on their name, email address, phone number, you know, first name, last name, email address, phone number for each person. Each one will be a JSON object, and it's a collection of them, so it's an array of those JSON objects, right? If I told you, hey, write a program to send an email to everyone in this group, right? So let's say I added, let's just do this. If I added an email property, right? Sorry, and this is colon. And if I said, this is John at example.com, right? And let me just copy this here. Paste this here. Paste this here. And then put a comma. You notice it underlines it as if I have a typo, right? Telling me that there's a problem there. This is going to be, this last one is James, right? And this would be Jane. Okay, so let's assume this program I'm writing, I want it to email everyone. I would have a function here that's function send email, right? And I'll say take person. Okay. And then here in my loop, rather than all of this, I would say send email. Oh, no, hold on. I want to keep that person line, right? So I don't have to rewrite that. So I'd say send email to person. So for each person in this list, it will send an email, right? And then in my email function, let's pretend like I have it actually send an email. I'll say console.log sending an email to person.email. So if I had some nice logic in here that would send email to the email address, when I run this, send an email to this, send an email to that. So if you had a mailing list that was in a spreadsheet, you could very easily take that spreadsheet, output it as JSON, and write code and just pass it to your code, and it will send an email to all of them.
Question.
Yes.
Please, can you put an array in a function?
You can pass an array to a function, yes.
So why can't we just do that? Why do we need this whole just?
That's a good question. Now, one thing that I'll say up front is that there are many ways to skin a cat, right? Some ways are better than others, right? Passing the array to the function has its benefits, and it actually is a good way to do it. In which case, I could take all of this, right? Take all of this code and come and put it here, right? Take this here, come and put it here, right? So that I don't have to call the function like that. But what I'm going to do is my parameter to my function, I'll now change it to people, right? So now I'm passing the array and I'm looping on that here. And I'm going to come here and I'm now going to come here and say, send email people. Right? And if I come here and I run this, the exact same result. So we've achieved the same thing in two different ways. Each way has its pros and its cons. I can't explain that right now because it won't make sense, right? But as we work, as we develop and we go into testing and reusing stuff, you'll find that, oh, some ways are actually better than others. Not all the time. In some scenarios, it's all about context, the problem you're trying to solve. But this is how, if you wanted to write a script to email everyone on your list, this is what you would do. This console log line here, you would replace it with logic that actually sends email. And it would do that. Okay. Let me add one. Let me make it a little more interesting, but using something we've learned already. So I'm just undo right now. That's what I'm doing. Okay. So here we have it back to where it was, right? Let's make sure that still runs. Now let's assume we wanted to only send emails to the mail people. Who can say how we will do that?
Conditional.
Conditional. Okay, so how do we do that? What's the keyword?
Gender.
If.
Right. If. Person. Right.
So yeah.
Gender.
Yeah.
Okay. I need to fix this. This is Visual Studio Code helping a little too much. And so now if I run the script, it will only send, so it's only sending to James and John. So let's say you had a mailing list and you have people who have subscribed and people who have not subscribed. You could use a conditional to determine who to send an email to. Right? So you see all the different concepts are coming into play. All the different concepts are coming into play. You can have a JSON object. I can add more attributes here. I can add, let's say this one here. I can, oh, come on. Sorry. Let's do this here. So here, I can come in here and add a subscribe. True, right? That's a Boolean, right? I'll say subscribed. True. And this guy, I can either put subscribe false or actually not even just put any subscribed on it. So if I come here now and I change my condition to say, okay, only email the people who have subscribed. If we come here and say if person that, because it's a Boolean value, we can use it directly as our condition. So if we say if person that subscribed, right? And we run this. Now we have John and Jane. They're the only two that have subscribed. James is a cheap guy, so he did not subscribe. So we're not sending him an email. Okay, so this is how you can, all those different concepts. We've used the loop, we've used the function, we've used an array, we've used JSON objects to make something happen. Those pieces come together. The way to work it is to think of small parts of the puzzle, small problems. So the strategy is you take a big problem and you break it up into small individual problems. Our big picture here is I want to send an email to all my subscribers, or to everyone on my list that has subscribed. So first thing is, okay, how do I define everyone? Each person is a JSON object. Okay, how do I define my list? My list is an array of each person, so it's an array of my JSON objects. Okay, now, how do I go through each person? How do I iterate over it? I use a loop, so I'm going to loop over them. Okay, now, so how do I now send them an email? I'll create a function that I call from that loop. And then in that function, I'll check if they have subscribed, and only if they've subscribed, send them an email. We don't have an else here, but if we wanted, so you can have an if without an else. It's perfectly fine. This is how you conditionally execute only one part. If we wanted an else, like let's say else, we can say.
So without the else, it will do nothing, right? It won't crash the system.
No, it won't crash. Okay. It won't crash. It will be an if, send an emails. And then if you don't provide an else, it's the same thing as else, do nothing.
Gotcha.
Yeah, so it just won't ever do anything if you have an else. In this case, we may want to say console log, person right is not a subscriber. Okay, and there, the benefit of an else right here is if you want to report, let's say you had a list with 10,000 people on it, right? A program like this would be super helpful. It'll send out a customized email to each person that has subscribed. But you also want a list of the people who haven't subscribed so you can market to them. You can have this output to another file and say, okay, output, if you haven't subscribed in the else, write their name into a file. Or send them a marketing email, say, hey, please subscribe, this is the benefit and all that. That's how your else would be useful. So very often when you have an if, you typically would have an else so that you can take more action on the exceptions. But you can have an if without an else. It won't break.
So the good news is we don't have to type all the 10,000 names. We can import them from a spreadsheet or something, right?
Yes, we can.
Man, I'm loving this now. Okay, now it's making, now this thing is making sense. All that loops and conditionals, you're now putting them together to do something practical with them. Awesome.
Yes. I've done so much work with stuff like this where, they're like, okay, we have, so the last project I worked on at the American Institute of Architects, they have a course system and they had to import over 100,000 courses and sessions. And they had them in Excel files, CSV files. Like, okay, now they had to import them into another system Question is, you could hire a whole bunch of people and have them work for weeks, manually copying and pasting and all that. But what I did was I sat down and in 15 minutes or 20 minutes wrote a script that just read that file, looked through it, and inserted them directly into the database. You know, it took about 15 minutes for the script to run, but when it was done, everything was in there. Right? That's the kind of problems that we solve with this. Is loops are great for when you have lots of data.
Wow. Wow.
So this is real life. When we go into the tracks next week, right, the backend track will learn how to read files from the server. So you actually learn how to read a file, a JSON file or a CSV file, parse it and write it to a database. It's one of the things that you'll learn. It's on the curriculum, right? And then you can just call it, I'll be able to call this and say, you know, node, hello, my file, CSV. And I would have written the program to see this as an argument, right? An input parameter into the whole script. Take this, look for that file, open it up, pass the contents, and loop over it right to the database. So this script right here, with a little adjustment, you'll be able to do that. Okay? But this is how you write the program. It's everything that we've learned so far has us able to write programs like that. We have all the knowledge that we need to write programs like that with a few tweaks. Okay.
While are you doing the back end?
Doing everything until it gets too hard.
So now, like I promised, and I'm going to introduce one last concept before we go, but understanding JSON objects will help us understand that relatively easily. But like I promised, everything we learn, we'll constantly reuse them. We're going to constantly use them. So we'll constantly go back because they all build up of each other. You can't use anyone by itself, right? But we'll constantly reuse them. We'll go back. You know, we've been declaring variables here. We've been doing console log over and over and over again. I think some people have it in muscle memory by now. We've been declaring strings and booleans and conditionals and loops, and we're going to constantly do that. Those are the basic building blocks of any program. So the last concept that I want to share, and I want to share this quickly, is the concept of a class, right? The concept of a class. And I actually made a very simple screen for it. And so a class, and this is all I define here. Now classes, of course, there's a lot of detail to it like everything else, but in its very simplest nature, a class is a blueprint, right, for a type of object. When a manufacturer wants to make a car, right, they make a blueprint. And then every time they make a car, every car is kind of almost exactly the same, but the properties are different. You know, a Toyota Corolla is a Toyota Corolla, but there could be a blue Toyota Corolla with leather seats. It could be a red Toyota Corolla with upholstery, right? It could be a green Toyota Corolla that's manual, a yellow Toyota Corolla that's automatic. The properties are different, but they're all Toyota Corollas. A class is like the blueprint for a Toyota Corolla, and each Corolla that's manufactured is an instance of that class. Let's use the people we created as an example, right? Let me clear this here. Okay, I'm going to clean this out, but we're going to create a person class, right? And the keyword for creating a class is like function, class. Class, person. And then you need a block, right? Now, we break convention a little here, but we're not breaking convention. It actually is convention. It's that classes should start with uppercase. Variables and properties should start with lowercase, but class definitions should start with uppercase. So we create a class person. How do you define properties on the class? Right? We can say first name, last name, gender, age. Right? And there, I've defined the class. Now, if I say, let person one, right, equals new person. I've created a new instance of person. Where this is helpful is if you look at, so this hint thing in Visual Studio is called IntelliSense, right? And you see it right now. If I say person one, and I say dot, you see what's happening here? IntelliSense is giving me all the properties of the person class. Tells me here that it's an instance of person. Tells me what the identifier is. That is giving me a list of the properties that are available. This is the benefit of using a class because there's a blueprint. Your IDE knows, right, understands. So if I say person one dot first name equals John. Person one dot last name equals Doe, right? Now if I say console.log person one, person one, right? And I run this. See what I have there? It looks like a JSON object, right? The only difference is it now has a specific type. And this is going to become very, very important. It won't make sense right now, but it has a specific type. Similar to how an integer is an integer, a string is a string, a float is a float, a boolean is a boolean. When you create a class, you define a new type. And that way you can constrain what that type does, what you can do with it. So the same way where if you try to divide by a string, you get not a number because I'm like, yo, it's not, the type is not integer, so you can't divide by. That's the same way your class can define what can be done on it. So let's say, for example, if I try to do person.occupation, right? Let's see what we get here.
So happy you can't spell thief.
Did I spell it wrong? All right. You see that right here? It's added to. It's added an unknown property. There's a way you can create a class and say it can't have properties outside of this. Or I can protect a property. If I say the gender is private, and anyway, we'll deal with this as we go on, but you can also protect the properties. It's called managing the visibility of a property, whether or not it can be modified, right, from outside it. So we're not going to deal with that today. We're out of time. but this gives you an idea of how to create a blueprint. And then
and this type only lives in this code, nowhere else.
It only lives in this code. Now, when we start working, you'll find that I can create this type here in the file so that it's available everywhere, and then I can import it into the code where I need it. Yes, I can require it or I can import it, right?
Okay.
Yeah, and there's a node way of doing it. It's called export. So I export the type so it's available, and then I import it wherever I require it, wherever I need it, and it becomes part of my programming stack. But remember, a class helps you define a blueprint for an object. And when you define a blueprint for an object, you essentially create a new type in your programming space. Okay? And this is where we end.
Excuse me, before you
Yes.
go. This new keyword is the first time I've seen.
Oh, yes. Sorry, I forgot.
Is that an object?
No, I forgot to explain that. This is how you create a new instance of the class. So this is how you create a new object. Yes. So for you, when you want to create a new object, you have to use the new keyword. Okay. If you don't put new here, you know what this means? You're trying to call person as if it's a function. And if I do that here, and I call this here, class reference person cannot be invoked without new. That tells you can't call it without new. So you always have to say new.
What if I did that with lowercase characters? I mean the person.
It will be unknown. So if I do person here with lowercase, then person is not defined. JavaScript is case sensitive. So your case must be exactly right. If you define a variable, the identifier. So if I say person one, if I say right, and I can say let person one. You know, normally you can't do two lets for the same variable. In this case, these two are two completely different variables. So uppercase person one and lowercase person one are two different things. Okay? They're two completely different things. So remember that, case sensitive. Sometimes the bugs you have is because you use. So in practice, variable names, lowercase. Class names, uppercase. The first letter only, uppercase, and then you camel case the rest of it. Okay? All right. Any further questions? We're over time.
Yeah. Okay. Yeah. No. So I had my class as lowercase, and once I changed it to uppercase, the color of the person changed. So.
Yeah. So you mean the class keyword or the class or this one?
The P.
Oh, okay. Yes.
The class P. Yes.
Yes. So it's important. It's best practice to name the class, the identifier for a class, be uppercase first letter. Don't make it all uppercase. That has a completely different use. Just uppercase first letter, everything else lowercase, and then camel case. If it's multiple words, like person, data, right? That's camel case with each word starting with an uppercase letter. Okay. All right. So we've been blasted and blasted and blasted. We're going to get into the phase of actually using these now. All right. Tomorrow, we're not going to do, we're not going to actually, we're not going to be doing JavaScript fundamentals tomorrow. We're going to go into an aspect. Can we please all mute? Okay, so we're going to go into an aspect of the course that's more softer skills, right? So our brains can take a rest from all the programming slamming that we've been getting. And we're going to explore the agile methodology, right? So tomorrow and Saturday, we're going to look at agile methodology, source control, GitHub, code reviews, Jira, the different tools and stuff that we use, and kind of get familiar with some of the terminology, okay? On Saturday, we'll also have a mock sprint planning. Okay, we'll have a mock sprint planning, so we'll see how it is that we plan the work that we'll do. We'll talk about the challenges or the problems that we'll solve going forward in the course. So it's going to be everyone, and I'm going to have that all set up in Jira. Okay. So the next 2 days, I believe, will be a lot more interesting and a lot less mentally draining.
Do we need to install anything? Or you gonna send us your Jira URL?
So the only thing you need to install is Git, right?
Okay, I got that's already here. Yeah, fine.
So if you install Git, you're fine. And that's the only thing you need installed.
What do you call it again? Git?
Git, G-I-T. It's in the welcome email I sent.
Oh, okay.
There's a link to it. Okay. So install Git, and then we'll talk through the framework and the methodology and everything. And actually, let me stop recording so that I can end the class.